This is the 32nd session on relative velocity. This is in continuation with the 31st session. So in this video again, I'll take up two more problems on shortest distance calculation between two moving points. So as I just mentioned at the end of the 31st video on relative velocity, this shortest distance method of using relative velocity concept is useful only when relative acceleration between two moving points is zero. If it is non-zero, then this method is not of much use. Then you better use calculus itself. Okay. Because if A relative is non-zero, then dv relative by dt is also non-zero. That means relative velocity is not constant. Now relative velocity not constant in general, relative velocity will vary either in magnitude or direction or both. In general, it will vary with direction also. So relative motion will no longer be along a straight line. It will be along some curved path. So this method will not be of much use. Okay. So whenever you are given the relative velocity shortest distance problem, first you must check whether relative acceleration is zero or not. If it is zero, then you apply this method. If it is non-zero, then better use calculus itself. Okay. So I'll take up another problem to demonstrate this concept. Okay. So I'll take up the problem. I'll write down the question. Okay. So P1 and P2 are two moving points. P1 and P2 are two moving what? Points. Whose initial coordinates are R0, L1 and L2, 0. P1 and P2 move along the coordinate axis. Q and P2 move along coordinate axis with constant respective velocities. Constant respective velocities u1 equal to minus u1 j hat and u2 equal to minus u2 I hat, where u1 and u2 are positive constants. Fine. So now find the shortest distance between the ships, between these 2 points. Between these 2 points using the relative velocity concept. Fine. This will discuss using the relative velocity concept. So this is the problem. I've written it here. Okay. So find the shortest distance between these 2 points using the relative velocity concept. All the details have been fully given. Okay. I hat, j hat, they are usual unit vectors along x and y axis respectively. Alright. So I draw the diagram. Okay. So first we should check whether A relative is 0 or not. That is the first thing we should check. Now u1 and u2 are constants. So constant respective velocities. So u1 constant, implying acceleration of P1 with respect to ground 0 for all times, and u2 constant. Any a2 g is also 0 for all times. That meaning relative acceleration between these 2 points in ground frame A relative, a2 minus a1, that is equal to 0 minus 0, that is 0 for all times. That meaning relative velocity between these 2 points is constant. Relative velocity between these 2 points is constant. That means that if P1 observes P2, then P1 will say that P2 moves along a straight line at a constant speed. Or if otherwise, if P2 observes P1, then P2 will say that P1 also moves along a straight line at a constant relative speed. So now it's a matter of choice whether we solve it in the frame of P1 or we solve it in the frame of P2. We solve it in the frame of P1 itself, okay? The problem solved as seen from P1. As seen from P1. Problem solved as seen from where? P1. We solve the problem as seen from P1, okay? So here A relative is 0, so it's nice to use the relative velocity concept itself, okay? So constant meaning P1 will say that P2 moves along a straight path, okay? I'll grab this, okay? So first of all, what we do that we find the initial relative velocity of P2 with respect to P1. Okay. So as I mentioned here, I am solving the problem as seen from P1. So initially P1 is here. Okay. P1 is here. P2 is here. This distance is how much? L1. This is a coordinate system, x and y axis coordinate axis. P2, x coordinate of P2 is how much? L2. P2 is moving leftward at a constant speed u2 and is moving downward at a constant speed u1. Okay. This is the situation at time 0. So at time 0 what we do? We determine the relative velocity of P2 with respect to P1. So u relative is just u2g minus u1g. u2g plus minus of u1g. u2g is what? u2 towards left. u1g is u1 downward. So minus u1g is u1 upward. Parallelogram method of vector addition, reverse and add procedure. This is the vector u1g. This is u1 reverse. u1g is u1 down. So minus u1g will be u1 up. And this is u2 left. So u relative is the vector sum of these two. That is vector sum of these two. So this is u relative. See, this is u relative. Now this is the initial relative velocity of P2 with respect to P1. Fine. As I mentioned just now, relative velocity is constant. So at any instant, relative velocity between P2 and P1 will just be this much. So at all instants, P1 will say that P2 is moving along this straight line at a constant relative speed of u relative. And as seen from P1, P1 is at rest. The shortest distance between P1 and P2 will be what? Perpendicular distance let fall from P1 on the line of motion of P2 as seen from P1. This is the shortest distance, R minimum. This is R minimum, okay, fine. Now we have to find this R minimum. So we join these two locations. This is L1, this is L2, this is L. Right angle Pythagoras theorem. L is just equal to root under L1 square plus L2 square. Okay, fine. So now we take this angle as phi and we take this angle as theta. So from this you can see tan phi is just L1 by L2, right angle triangle. Tan phi is just equal to L1 by L2 and tan theta is equal to U1 by U2. U1 is also U1, U2, right angle triangle, diagonal, Pythagoras theorem. So right angle triangle concept. So tan theta will be equal to U1 by U2 and tan phi is equal to L1 by L2. Tan phi is just equal to L1 by L2 and tan theta is equal to U1 by U2. So now this angle will be how much? Theta minus what? Phi. Okay. So R minimum will be equal to how much? This is L. This is the right angle triangle. Right angle triangle. This is the hypotenuse L. This is the shortest distance. This angle is theta minus phi. That will be L sine theta minus phi. Alright. Now what we'll do, we'll expand this by sin A minus B, trigonometry rule. So this will write as sin theta cos phi minus cos theta sin phi. Sin theta will be how much? Tan theta is this much. By trigonometry, sin theta will be how much? u1 by root under u1 square by u2 square into cos phi. Cos phi, tan phi is this much. From trigonometry, this will be L2 by root under L1 square plus L2 square minus cos theta sin phi. Cos theta will be how much? u2 by what? u2 by root u1 square plus u2 square. And sin phi will be how much? L1 by root under L1 square plus L2 square. Now this and this, they will cancel out, they are same. So this becomes L2 u1 minus L1 u2 by u1 square plus u2 square. This is the shortest distance between the 2 points in course of their motion. But wait, one thing, this answer is not complete. Why? Because in this problem we have assumed that, it is seen from the diagram that we have assumed that theta is more than phi. But theta need not be more than phi, theta can be less than also phi also. So in this we have assumed, it has been assumed that theta is more than phi. This we assume, and then we have obtained this R minimum. But theta need not be more than phi, theta can be less than phi also. So but theta can be less than phi also. In that case, then how will the new situation look at? It will be like this. See, this is P1, okay. Theta is less than phi. This is P2, okay. This angle is as usual phi, okay. Now we assume that theta can be less than phi. So u relative should be in this direction. This is theta. In this case, shortest distance will be what? This one. This will remain L. This is as usual L. This is phi. This is theta. See, right angle. This is equal to just phi minus theta. So in this case, R minimum will be equal to L sine phi minus theta. This will be R minimum. R minimum will be L sine phi minus theta. Now, if we again expand it, as we did in first case, when this was, we assume theta is more than phi, and this everything will be same, with the only difference that we will get R minimum as L1 u2 minus L2 u1 by root under u1 square plus u2 square. In that case, R minimum will be this much. And if theta is more than phi, the R minimum is this much. And if theta is less than phi, in this case, R minimum will be this much. So how do we, but we don't know whether theta is more than phi or less than phi. But we are only interested in finding R minimum. We simply take the modulus of this. So we are combining all of them. So we take R minimum as mod of L1 u2 minus L2 u1 by root under u1 square plus what? u2 square. देखिए. So this is R minimum. This is going to be the final answer. This case, when we take modulus, then both the cases are covered in this expression. So this is the final answer. Fine. So R minimum will be mod of L1 u2 minus L2 u1 by root under u1 square plus u2 square. Alright. This is going to be the final answer. Alright. So both the cases are covered in this. Alright. Fine. So this problem I have discussed fully. Alright. Now I will take up one more problem on shortest distance problem. Okay. I will take up one more question on shortest distance problem. Okay. Fine. This I will rub it. Okay. We take up one more question on shortest distance problem, okay? So I write down the question here. P1 and P2 are two moving points. P1 and P2 are two moving points which are moving along two straight lines at constant equal speeds. At constant equal speeds u each. The angle between these two lines is 60 degree. Angle between these two lines is 60 degree. At t barabar 0, the situation is as shown below. The 2 points are located as shown. As shown below. At t equal to 0, the 2 points are located as shown below. I'll write down the question, then I'll draw the diagram, okay? Find the shortest distance between these 2 points in course of motion using the relative velocity concept, okay? So I'll draw the diagram. See, it's like this. These are the two lines. Angle between these two lines is 60 degree. At time 0, P1 is somewhere here and P2 is somewhere here. This is the intersection point O. This distance OP1 is equal to L and OP2 is equal to 4L. P1 is moving at a constant speed v towards O. P2 is also moving at same constant speed v towards point O. Sorry, U, not V, U, sorry. P1 is moving at a constant speed U towards O and P2 is also moving at the same constant speed U towards O. Now we have to find the shortest distance between these 2 points using the relative velocity concept, okay? Now again, we first check whether A relative is 0 or not, as we did in the previous question of this video. So that you can see, because see, velocity of P1 is along straight line at a constant speed u, so acceleration of A1 with respect to ground is 0. And P2 is also moving along a straight line at same constant speed u, so A2g is also 0 for all times. This means A relative, that is relative acceleration of P2 with respect to P1, that is equal to A2g minus A1g, that is 0 for all times. This means that as seen from P1, P2 moves along a straight line at a constant speed, or as seen from P2, P1 moves along a straight line at a constant speed. So since A relative is 0, so it is better to solve it by relative velocity concept. So A relative 0 meaning as seen from P1. So we are solving the problem as seen from P1. As seen from P1, P2 moves along a straight line. P2 moves along a straight line at a constant speed. Relative speed equal to V relative. Now that constant relative speed is same as the relative speed between these 2 points at time 0. That is just the initial relative speed U relative. Okay. Because if any physical quantity is constant, doesn't change with time, then value of the physical quantity at time t is same as that at time 0. So relative velocity between these 2 points is constant. So that means constant relative velocity is same as the relative velocity at time 0 between these 2 points. So we'll say that with respect to P1, P2 moves along a straight line at a constant relative speed of U relative. Okay. So now what we have to do, all we have to do is to find this u relative and then draw the normal. Okay. So I'll rub the upper portion. Okay. So what we do now, remaining I have explained fully, because as seen from P1, P2 will move along a straight line at a constant relative speed of u relative. Okay. So what we do now, that we find u relative now. So now u relative is the relative velocity of P2 with respect to P1, u P2 P1 slash g. That is just equal to u2g minus u1g. That is just equal to u2g plus reverse of u1g. Okay, u2g and reverse of what? u1g. Fine. So I draw the diagram here. I'll draw it here itself. Okay. So this is P2, huh? u2g. u2g is nothing but u in this side. And u1g is like this. So minus u1g will be like this, reverse. This is minus u1g, u. This is parallel to this. This is also 60 degrees. So this is also 60 degrees. So u relative is the vector sum of these two. U relative is the vector sum of these two vectors, parallelogram law of vector addition. So like this. Like this. It is u relative. So we continue this like this. Okay. Now we are solving the problem as seen from P1. P1. Shortest distance between now with respect to P1. P1 is at rest. P2 is moving like this. The shortest distance between P1 and P2 will be the perpendicular distance from P1 on this line of motion of P2 as seen from P1. This is the shortest distance, R minimum. Here it has slightly become clumsy, but don't get confused. U P2 overwritten here. Okay. So we have to find this R minimum. All we have to do is find this R minimum. That's all. So now we join this with this. This is given to be L. This is given to be how much? 4L. Okay. This is given to be how much? 60 degree. This is right angle. This is U relative. Now this distance, let this P and P2 be D. Let P and P2 be equal to D. Okay, fine. Acha, note one more thing. This is 60 degree, this is also 60 degree. This angle will be 120 degree by geometry. Now these two U and U have equal magnitude, so U relative will bisect the angle between these two vectors. So this angle will be, this is 120 degree, so this angle will be 60 degree. Let us call this angle as theta. So this angle will be 60 degree minus theta. This is 120. U relative bisects the angle between these two U's, so along 60 degree, U relative. This is theta, this is 60 degree, so this is 60 degree minus theta. This is D, this is right angle triangle, D is the hypotenuse, this is 60 degree minus theta. R minimum by D is equal to sin 60 minus theta by geometry. Is equal to D sin 60 degree minus theta. Fine. R minimum is equal to D sin 60 degree minus theta. Now we first have to find D. Now this is a triangle. We can use the cosine law of triangles. So D is root under L square plus 4L square. L square plus 4L whole square minus 2 into L into 4L into cos of 60 degree. Cos 60 degree is 1 by 2. This is well known. This becomes 16 plus 1, 17 L square minus 4L square, any L root 13. Okay. So D is equal to L root 13. Now we only have to determine theta. Now question is how to find the value of theta. That is the question. For that we can use the sine rule of triangle. L by sine theta is equal to D by sine 60. You can see this triangle, sine rule of triangle, A by sine A equal to B by sine B equal to C by sine C. That we can do. So this triangle OP1 P2, D by sine 60, D by sine 60 degree is equal to L by sine theta. Fine. So D becomes sine theta becomes L sine 60 root 3 by 2 by D. D is L root 13. So this becomes root 3 by 2 root 13. This is equal to sine theta. This is sine theta. Fine. So now what we do, sine theta we obtain. So cos theta from trigonometry will be root under 1 minus sine square theta. So 1 minus 3 by 52. Right? Square root 1 minus sine square theta. 1 minus 3 by 52. That is just equal to 7 by root 52. So cos theta is equal to 7 by root 52. Sine theta is equal to root 3 by 2 root 13. Okay. This can be simplified further. 4 into 13, so 2 root 13. So cos theta is equal to 7 by 2 root 13. And sin theta is equal to root 3 by 2 root 13. And cos theta is 7 by 2 root 13. Alright, fine. Now we must substitute this in this answer. I'll rub this, okay? So d sin 60 minus theta, this I'll rub, okay? Fine. So R minimum is equal to d sin 60 minus theta. I'll write the complete the calculation here. So R minimum will be equal to d sin 60 minus theta. Sin 60 degree cos theta minus cos 60 degrees sin theta. Okay. Now d is equal to how much? L root 13. So L root 13. Sin 60 is root 3 by 2 into cos theta. Cos theta is 7 by 2 root 13. Minus cos 60 is half. Sin theta is root 3 by 2 root 13. So root 13 goes away, you can see. Root 13 goes away. That meaning, how much will it be? 7 root 3 minus root 3 by 4. So L into 6 root 3 by 4. Meaning L 3 root 3 by 2. This is the required answer. This is the shortest distance between these 2 points in course of their motion. The shortest distance between these 2 points in course of their motion will be 3 root 3 by 2. This is the shortest distance. This will be the required answer. I hope it is fully clear. Alright. So this is the 32nd session on the relative velocity in which shortest distance problem has been discussed. Okay. I will take up one more video on this chapter on shortest distance calculation in the next video. And then I will pass over to relative velocity collision problems in 2 dimensions. Okay. So this I will close it just now. You can go through it. You go through it properly. You will fully understand. There is no problem. Okay. Fine. I close this session here.